So before we move on, I did want to point out, noticing these t-charts here. So particularly in 2B, because that's one where it would really be obvious here. We went down 4. So if you notice from this t-chart here to this t-chart, my x values didn't change, but my y values went down 4. And so what we're building up to is you can just know these down here and build your t-charts from there. So that's what we're going to model in this next example. Here we're going to talk about reflections. So our parent function in 3a is our absolute value function. All right, so 2, 1, 0, 1. So talking about, is this in the x-axis or in the math or outside the math? Negative. If it was inside the absolute value sign, it would be affecting. Since it's outside the absolute value sign, this is going to affect my y values. So we call this a y dilation of -1, or you could call it a y reflection with the of -1. So that means every y value is really just going to be multiplied by -1. So I can take my x values here, and I can just multiply my y values by -1. So if you were to graph the original, and then look at this, well, what's going to change? This is going to be -2, -1, 0, 1, 2. What's changed is only my y values. And I did not have to really come up with a whole new t-chart. I just needed to use my parent function here and multiply my y values by -1 as illustrated in my equation. For 3b, my parent function is just my linear equation, my identity function. So this is -2, -1, 0, 1. So there's my parent function. If I graph y equals -x, well, that actually is just the equation with a negative slope vector here. So in 3a, it's a little obvious. What did we take? We took the green absolute value function and we reflected it over the x-axis. So our y values changed. We took the green function and we reflected it over the x-axis and got our blue function. For 3b, you could actually say this two different ways. You could say this is a reflection over the x-axis, or you could look at it as a reflection over the y-axis. For this one, it would actually be either. So you could label this a y distortion of -1, or you could label this distortion of -1. Either way, if I took and I multiplied these values by -1, or I took and these values multiplied by -1, I would end up with my same final t-chart that would produce. All right, if we're looking at 4a, so my parent function here is my x squared function. -2 squared is 4, -1 is 1, 0, 0, 1, 4. So this is 2 times x squared. It is not included in the x squared. It is not included in the squaring. Therefore, we would label this y dilation of 2. So what we're going to do is we are going to take my parent function over here. I'm going to leave my x values alone. I'm going to take my y values and I'm going to simply multiply them by 2. So just these values right here. I'm going to multiply by 2. So 4 times 2 is 8. 1 times 2 is 2. 0, 2, 8. So if I were to graph my original, oops, hopefully a little better than I did, and then graph my new one, 2, 8, negative 1, 2, 0, 0, 1, 2, 2. Well, that's why my graph this should be. 2, 8, you can kind of see this is a dilation. It's a stretch, but it actually made it thinner. Why does it make it thinner? Well, think about silly putty. If you have silly putty in your hand and you stretch it vertically, what happens? It actually gets thinner. What's nice about doing this method here, where we just multiply from your parent function's teacher, is it will always give you a full V in absolute value. It will always give you the values you need because you start with those values, and you don't have to worry about, first of all, choosing the correct X values to plug in, or do you have to worry about actually plugging it in and making calculations here? Because most of the time what you're going to do is you're either going to be adding basic numbers or multiplying them. So it's actually a little simpler to use. For B, well, my parent function is my answer value. My Y values are then going to be 2, 1, 0, 2. My parent function should look like this. Now, this 1/3 is inside the math, so it's going to be an dilation. And as I talked about in that earlier video, x's live in opposite. So instead of multiplying by 1/3, we are going to multiply by the reciprocal. So the reciprocal of 1/3 is 3. And I'm going to do that to my x values here because it is an x. This becomes -6, -3, 0, 3, 6. My y values are actually just going to stay the same. So that becomes -6, 2, -3, 1, 0, 3, 1, and 6, 2. So this dilation is a horizontal stretch. And think about silly putty again. When you stretch it horizontally, it gets flatter and wider. So I'm actually going to stop us here. The rest, this final problem, we will do together next class. I fully expect there to be problems and questions that you don't understand. So come with any questions you guys have next class. Your homework is only the odd problems on your calendar. And so the answers are on the back of the book, but come with any questions you have. We're going to spend really 3 classes over 2.7 and 2.8. So you look at the calendar, we have another day, well, another half of a class to finish 2.7. So I fully expect there to be questions. If you have them, or 2.6, if I wasn't there to answer those questions today, bring those with you and we will go over those together. Try not to get too frustrated. Give it your honest best attempt at homework, and we will go over any questions you guys have next class. Between then and now, feel free to email me. Otherwise, next class, we'll kind of pick up from here and we'll go over any questions and kind of help us get started again.